I'm very happy to say that this test was very successful.
And the goal is to drive on a track through the city to generate a high-definition map of the road, as well as to try to detect road damage and road wear on this track. And as the partner, it's our interest to look into the utilization of this data in the context of automated driving.
In the second test campaign, we have GNSS signals, in this case GPS and Galileo, plus the high accuracy service in real time for processing the GNSS. But in addition to this, we will have the IMU for the tunnels and where we don't have a good reception. And we are getting odometer data too.
And now you can see in this track, we have here the IMU from digital vehicle. And then here we have our navigation computer with a Raspberry and a Septentrio Mosaic receiver. And now you can see.
We used the Leica Pegasus, which is a MMS with LiDAR. There is inside one LiDAR and 6 cameras and a GNSS antenna. This system allowed to model the environment, and with it we can use point clouds to see the environment.
So the main challenge was here, this MMS. So this MMS was provided by our partner GeoSat, and it is really heavy. So we need to make this mounting rack really sturdy in order to support the weight.
So at the moment we have visibility towards 7 satellites. So it's a good reception.
We have the same setup as in the first one, with the addition of a chip-scale atomic clock connected to our receiver, and this helps improve the accuracy of the navigation solution and improve the overall navigation of the car.
But the car is driving autonomously right now.
So the difference between the past tests is we used another mobile mapping system with new IMU, another GNSS antenna and a powerful LiDAR. The point cloud will be a lot precise and with more dense points.
And those information is taken to the navigation computer and fused into an algorithm to determine the trajectory. So they use the GPS, GNSS, Baidu information, and on the other hand, they use the IMU data from our vehicle and also vehicle speed, and fuse all of this together to find a good trajectory.
So now I will explain a bit our system. So like before, you already saw some data from the camera, LiDAR and radars, and these sensors are mounted around the car, and with the sensors we are doing perception. So as an example here, you can see now the colored dots. This is the LiDAR data, and in this vehicle we are using the LiDAR data for object detection and also for localization. So maybe first for the object detection. So as an example here, you can see a pedestrian. He is detected and also predicted. So we're using this data for object classification and then also the next step for prediction. This data is fused with camera and radar data. Here you can see as an example a bus driving, or here's another bus. And also these buses are predicted on the current state and also how the road networks look like. So what we have here is we have a road network, and our vehicle needs a road network to drive automated. So in our map, we have one layer is the road network, and the second layer is then the 3D point cloud for the localization. So like you can see here, it's a 3-dimensional point cloud. And with the live LiDAR data, the system is doing a localization. So at the moment, it's using all these white thick dots on the screen for the localization.
We already did some preliminary data analysis, and what I can say at this point in time is that we hope that with this data we can assess the accuracy of trajectory determination in urban areas, semi-urban areas using the technologies of the project.